Welcome to Tolbert's class. This is Mr. Tolbert's class. This is chapters 5 and 6. This happens to be the fourth lesson in a series from chapter 5 and 6. This is lesson number 4. Once again, this is lesson number 4. And this happens to be the third section of chapter 5. Okay, this is all physics that's happening. Once again, Mr. Tolbert's class, lesson number 4. Here are the things that I'd like you to be able to do today. Determine the net force acting on an object. Figure out what is your equilibrium. Figure out your balance, Daniel-san. Find your balance. Draw free body diagrams to represent forces acting on a body. The sum of all the forces acting on a body are called the net force. We talked about net a couple times. We talked about when the forces cancel out, that net force is 0. So the sum of all the forces here is going to be the net force. The question here is, in what direction is the plane, what direction will this plane go? Now let's look at what we have here. Let's analyze this particular picture. So it looks like gravity is pulling down a negative 50,000 newtons, but it looks like there's at least 55,000 newtons going upward or lift. It looks like in one direction I've got a negative 20,000 newtons, and the other I got a positive 20,000 newtons. So this one, and let's make this a little easier to read. So this direction one and that direction one looks like they cancel out, and that's 0. But my up versus my down, my newtons pulling down was 50,000. My lift was 55,000. It looks like my net is going to be $5,000. In which direction will it be going? It'll be going in a positive direction. So this is what's left over. Adding forces. To figure out how or if an object's going to move, you've got to look at all the forces that are acting on it. Like the forces acting on the plane. You've got your weight, you've got your drag, you've got the thrust, you've got the lift. Forward is the thrust, drag is going to be that air resistance, weight is going to be the gravity pulling on it at 9.8 meters per second, and lift is going to be what those wings do that gives us lift. Find your balance. When several forces act on the same object, that net force is 0. Once again, when they cancel out, the net force is going to be 0. If they don't cancel out, the net force is not 0. That makes sense. In this bottom example, I have 10 minus 7, so it's no longer 0. Looks like my net force is going to be 3. And it's not just 3, but in which direction will it head? It's a negative direction. So that one will head west in that negative direction. The up above one, I have 10 minus 10. 10 minus 10 gives me 0. So the net is 0. When the forces are balanced, the net force is 0. When the net force on an object is 0, it is said to be in equilibrium. Find your balance. Let's back that up a little bit. Now, there's a new term that we're going to learn. This new term is what we call the normal force. The normal force is created whenever an object is in contact with the surface. The normal force is equal strength to the force pressing on the object which has been placed. So the normal force, once again, is called supportive force, but it also being thought of as what keeps you looking normal. If this is the planet Earth, let me back it up a little bit here, y'all. If this is the planet Earth, let me make a quick drawing. and you are standing on the planet Earth, the Earth is going to be pulling down on you with the same due to gravity, but you are counteracting that force, and that is your normal force. Now, if you don't counteract gravity with the normal force, what's going to happen? That means gravity, if gravity is increased, it keeps on increase, what happens? Boom, this guy gets smushed, and you're dead. So, that's what happens if you don't stay normal. Normal force has equal strength to the force pressing on the object when it's on, or typically it's equal to the weight. Here's what a free body diagram looks like. A free body diagram is basically a picture in which case we keep track of our vector arrows to show us where the forces are acting. This is a picture that I would love you to copy for number 8 in your guided reading 5.3. But this is a free body diagram showing the book. The book has 4 legs. Each of those 4 legs break apart the force that's being acted on it, which is this weight. Its combined weight was 200 newtons. Okay, so each of the 4 legs is 50 apiece, but we've got one leg that's got a little bit more. Why do we have a little bit more? Because on this particular one, I've got some books at rest right over that 3rd leg. Okay, so we have to add that 30 to the 50. 50 plus 30 gives us 80. So the net force on acting on this table is 0. Alright, and that is the end of the 4th lesson. Thank you.